anteckna frågor, eller kanske det är så få så att du kan se själv?
Det skulle vara bra om du börjar med att bara kolla se om volymen är bra.
Okej.
Volume's good. Okay. Yeah. Hello everyone. I am Martin Stewart, and today I want to show like a little thing I've been doing with Elm and audio. So in Elm, those are familiar with it, you have your view function, the thing that tells the program what to show on the screen. And what's really nice about this view function is you just take in the state of your program and you spit out HTML, and that appears on the screen. You don't need to worry about like what HTML was visible earlier. So you don't need to worry about like, oh, I was on this page, now we're going to this page. How do I remove the stuff from the old page, draw the new stuff? You don't need to worry about that. You have the Elm virtual DOM that automatically updates things for you. Like, you know, if you were using React, same idea. This is good. You avoid this sort of bug. Here we have these tabs open. You're supposed to like hover the mouse over one of these tabs that the red arrows are pointing at. And when you do that, then the like little drop down appears. And here I have managed to get two open at once by just filling my mouse back and forth real quick. You could set up an L program that would guarantee that this can't happen, regardless of logic bugs, because it would just be an unrepresentable thing in your state. There's no way to like forget to close one and then open the other tab, that sort of thing. Funny story about this real quick. I remember someone else posted on Twitter a while back the same bug, and I couldn't find it, and I wanted a good example of this. So I just went to my old college website and just found one here, like just fiddled, and immediately broke. It's like first attempt and it failed. So the very classic web development. Also, people who know me might know I like making games. Games often have sound effects and music in them. So normally when you do sound effects in games, or at least like in the past when I made games, the like intuitive approach is you know, you have a start sound function, you have a stop sound, you have a set volume, maybe a few other functions, and they just, you know, well, they do what they say. And this is very straightforward. It's an obvious API, but you get into these bugs where like, you know, you start the background music, and then you hit the pause menu. You probably should stop the background music while the pause menu is open. How many ways can you open the pause menu? Like maybe hit the escape key, or maybe it gets triggered if you do something else, or you also should stop the background music when you reach like a game over screen. And now you got to remember in all these cases, oh yeah, I got to call that stop sound button on my music that's playing. If you forget, then you have the music playing during this other screen, and you're probably starting another song, so you have two songs playing on top of each other. That's no fun. If we have this view function that just automatically handles updating the view for us, and we don't need to worry about, again, like having this one page and this other page drawn at the same time. We don't need to worry about two tabs open at once. Well, can we do that with audio? Can we do the same thing where instead of saying, let's start this sound, let's stop the sound, we instead just say, this sound should be playing, and then a while later we say this sound, or like, we say all the things that should be playing right now, like audio, and then later we say, these are all the things should be playing, and we just have some kind of audio DOM that figures out the difference between the two and stops some sounds or changes some others or starts new sounds. So that's sort of what I've explored here. Here's a little test bed. Oops, should have restarted that. Here's a little test bed to mess around with this audio idea. So this is just a game. Move with the arrow keys. Move around. Oh, I should avoid the circles. Okay, let's avoid the circles. Oh, I didn't avoid the circles. The difficulty might need a little bit of tweaking, but that doesn't matter for this demo. And here then is like a little pseudocode example of the code for this game. we're not really interested with how we initialize it, or the code that runs the game logic, or even the view. We're actually not interested in this either, this little ports thing, but that's needed to make the audio work. But we are interested in this bit. We have this audio function, and we get in our program state, and then we return audio, whatever that might be. In the case at the moment, we have this model that has start time. In this case, start time is just like the instant I hit an arrow key, that's the game has started. What time was that? That's the start time. And then you die. In either case right now, we just play silence. There's no sounds. So the first we can do is we can add that if the game started, we can call this audio function. We tell it we want to play the pop sound. And when do we want to play it? Well, we have start time, and we add this little offset right here. So after a couple seconds have passed, we play a little pop sound. So the pop sound corresponds to this text that appears here. Anyone hear it? Oh, dang it. Okay, it's very quiet, but hopefully you'll hear the music that'll play later. But just that sound plays. It's literally, that's the sound that plays. This is getting a little crowded, and all this stuff up here is not interesting. So let's just take this function here, and let's just scoot it to the top. So we just, from now on, we're always looking at this bit. Nothing interesting happens here either. So we got that sound. It wasn't very loud to begin with, so it's a little silly that I'm making it quieter now. But you see here, we're just, instead of like running a set volume function, we're saying we have this audio. This is when it starts playing. This is what it is. And now we're passing it to this scale volume. So we're defining what should be playing and when it should be playing. No point in playing it. You're not going to hear it if it was not audible to begin with. Likewise, let's add some music. So now we have this. We have this group function, and this just takes multiple audios, puts them in a group. So we have our pop sound, and we have some music. And the music here, this is the sound we're going to be playing, and here's when we start playing it. So yes, that plays. Thank goodness. And now, okay, I heard the pop sound. Whatever. Yeah, we got music playing. Cool. And it's going to play for a little bit. I'm just stalling for time now because it's going to stop in a moment, and you'll see why, or I'll explain why in a moment. Okay, one more. I should have made it shorter. There we go. What happened? Well, we told it to start at start time, but the song's 30 seconds or 28 seconds long. So there's nothing more to play. It stopped. So what we can do, okay, well first we can add a little volume slider. Was that too loud for the people sitting right next to the speaker? Actually, I'm going to lower it anyway because I think the people in the live stream are going to think it's too loud. So I'm going to lower it to hang on, we'll just see, quiet, loud, quiet, loud. So yeah, we have a little slider. We don't need to worry about again with the set volume thing. If this was just a set volume, you could think okay, we'll just call set volume every time I adjust the slider. But then, oops, we forgot to call set volume when the game started, for example, and now you have some value that doesn't match the master volume in your model. But here, because of the way we've defined it, there's no way to forget, because you're not responsible for setting volume. You're just responsible for saying, this is what audio is, and then everything else, the update, is handled by the audio DOM, as we can call it. But yeah, let's make it so the song loops. So here what I've done now is we have this audio, but now we have a little with config, because now we can add this a record that specifies a little bit of extra stuff. So playback rate, if we want to make it go faster or slower, but right now it's just 1, so that's unchanged. We can change when the song starts, but that's just 0. But we also have defined this loop now. So we're saying the loop ends here, and I think that was the loop that just happened right there. So at 28.3 seconds in, the song loops, And where does it loop to? It loops to the 5-second mark, because the first 5 seconds is like an intro. So you don't want to go back to the start of the song, because in that case it's like a bit of a weird jump in the audio. So yeah, that was the loop again. It's not too noticeable. Okay, we don't need to listen to that all the time though. So yeah, we added the loop. What else can we add? What we're doing here is we're checking, are we dead? That is to say, are those blue circles, has one of them hit us, then we're dead. And when we're dead, then we figure out what time we died. Using that information, then we can, here for example, the underscore is invisible, but we could assign a variable here to know what time our character died. Right now we're not doing anything with that, but we moved our music inside the nothing case. So what we're saying here is, if we're not dead, play the background music. So just skip that a little. The music stops now when I die. So again, we don't need to worry about like, oops, I forgot to stop the background music when the character dies. That's just handled for us, just due to the nature of where we put the code. But when we do die, let's play game over sound. So here's the time we died at. So we play this game over sound at that time. Oops. So we can skip that a little. Yeah, we can do that. And then one final thing, the little blue circles, let's have a little sound effect for those when they appear. In this case, I'm just using the pop sound again. This code's a little more complicated, so I can go through it real quick. We have this function here called bullet pattern. So this is a function that returns a list of bullets that are on screen. So it returns a list of the bullet's creation time and the bullet's position. So each one of these blue circles then has some creation time, like when it was created, and some position on screen at the moment. So this function isn't just used for audio then. The function is also reused for actually drawing the blue circles, and is also used for collision detection then. And what we do then is we sort the bullets by which bullet was most recent, and then we just take the 5 most recent bullets, and for each of those bullets then we play the pop sound when at their creation time. We could just take the entire list of bullets and create a little audio. We call this audio function for every one of the creation times, but like this pop sounds like half a second long, so we have like hundreds of audio things, even if like the majority of them have already finished playing, so there's no point in keeping them around. And then we just group them so that we can have it as a single audio value that we then put inside our larger audio group. Let's listen to that then. Skip ahead. And yeah, that's about all there's to it, like just the basic concept behind this. It's kind of hard to sell right now when I've only showed you this and I haven't showed you like actual code using the alternative. And just kind of like believe me, the alternative is more confusing and more error prone. Take that as you will. One thing I did do, so this audio code I have now, it's part of a package I've written called Elm Audio. And so I've used it for a couple games and it's worked out nicely. But one thing I also did was there's another game, what was the game called? It's a little platformer game. It's also a simple little example game made by someone named Audrey in the Elm community. And that game uses the standard start, stop, set, volume thing. And what I did then was I swapped out that for this Elm Audio approach instead. And the code became much more simple because instead of needing to have these audio commands mixed in with the update logic for like running the game, they were separate in a separate function. And so not only was this less error prone, I should say, it's hard to say that it was actually less error prone because it's not like this game had bugs in it involving audio, but it was more simple. The code was simplified because of this, because you didn't have all this mixing of playing audio along with the game logic. So yeah, I personally find this to be a useful approach for audio in games. Is it useful for other things though? Maybe. The issue is, well, for starters, most websites don't have any audio at all, like, or unless you have like a video, but that's completely handled by the video then. So, or like if you're like doing a podcast, you use an audio tag, and then you get lots of pre-built stuff included. So there's like no point in reinventing that. Another drawback, if you were really like, let's say you wanted to make your own Spotify, so you can like load in a playlist of songs, play them one at a time. This could probably help you with that, like handling the logic of playing one song at a time, that sort of thing. But this has a drawback that once you load in a sound, you cannot unload it, which seems like a bit of a drawback. The advantage with this is that every sound you can reference, like in the model you saw there was like model.pop sound, model.music, or model.game over. Those are guaranteed to be there because you can never unload them. If you can unload them, then you don't really know if that sound's really there, and what happens if you try to play something that's not there. Should just get silence. That's kind of a sucky error message, is just the thing doesn't make any sound anymore. So it is a bit of a drawback, like makes one use case better, which is just situations where you want to make a game and all the sounds are already there, but it doesn't work so well then for Spotify or something where it's a potentially unlimited number of sounds you want to load in. So there's trade-offs. So it doesn't work so great for Spotify things. It doesn't work so great for like playing YouTube. If you wanted to do something like make your own audio editor, something fancy like that in the browser, first off, I just think in general that's not a good idea because Web API is it's not good, frankly. It's a mess. And so I kept myself to a very simple part of it to implement this. But even if you were like dead set on implementing your own audio editor inside JavaScript, it would be, it's complicated essentially. And so this is probably too limiting for that. There's actually another Elm package called Elm Web Audio or something, or Elm Audiograph, that would do this better. So again, games. I have solved audio for games. Yeah, that's basically all there's to it. That's all, folks. Yeah, any questions? And I can check YouTube. No questions there, so it's all on you. Any questions? Yes, this package is published. I might have sold it now, like this is something I did a month ago or a week ago and like want to tell it to the world. This thing is like 18 months old at this point. Pandemic. Haven't presented it to many people. But yeah, it exists. You can try it out if you'd like. If you try it out, let me know. Let me hear what you think. Any other questions? It's a good question. Yeah, so here I've kind of ignored the part where like, how do you get the sounds into the program? Essentially, that does require commands then. You need to send out a load audio command, and then you get back a result that says like, here's the sound, or it failed, like here's a list of errors it could have been. But once you get that sound then you can just use that when playing audio. So in this presentation in particular, I basically have a loading state and a loaded state and a failure state. So in the loading state, I'm just loading in all the audio, and once I've realized that all the audio is there, then I jump to the loaded state, and now I'm certain that all the audio is present. And I don't need to worry about if something doesn't exist, because I can't unload sounds, and I've made sure everything's loaded. But I haven't showed that part of the API, because I wanted to more show the audio DOM idea than I wanted to show implementation details. Why I can't unload because if there was an unload command, then the issue is if I go back real quick. Here, for example, we have audio.audio, and here we have pop sound. But if I could unload pop sound at any point, then there's no guarantee that this is really here. The user might have unloaded it, and in which case, what should this do? And I could just like not play anything, and like that's not the end of the world. Stupid user for unloading the sound they wanted to play. But it's like excuse me, it's a possible error case that just why introduce that if it's not needed for what I want to use this for, which is situations where you can load in all the sounds at once, and you don't need to unload them because there's just not that many of them. But if someone comes along and goes, well, I have my personal use case that really could use this unload sound, then then we can discuss it. But might as well start with the ideal before you try supporting everything, and just see if it's necessary or not. So it could be something that's worth doing. Yes?
Is there any way you can do fading based on basically where you are on the screen? Or
Yeah.
so basically ambient sound that either gets stronger or...
Yeah, so there'd be two approaches to that. One is like this approach here, where you just change the value as like if you have a character moving around, then on every animation frame, you're updating the game 60 frames per second. Your audio function is changing what the scale factor is based on your position to that audio source. That's the API could support some notion of like 3D space with audio position and stuff. I don't see that much value in it because there's probably a lot of varying use cases, so it's better to just let the user do it. But one thing that is possible, so suppose you just want to fade out a sound. It's not dependent on any slider, it's not dependent on character position, it's just at this point in time it's full volume, at this point in time it's zero, fade between them. And that's possible. There's a function called scale volume at, and that then you give it a list of time value pairs, and so then it just plays through those. You could fade out then without needing to have any kind of like constantly updating some value if you just wanted to smoothly fade out. I didn't show that here because I was having difficulty thinking of how to work that into my little game without but given how short this presentation was, maybe I should have. Oh well. Yep. Tree shaking is just done automatically by Elm. The compiler can tell, is this function reachable? No, then it's not compiled, or it's not included in the bundle. Things like, what's the term for it? Where you don't send all the code at once. Lazy loading, thank you. That is not supported by Elm. There's talks about supporting it, nothing's happened. But in practice, it's not, or at least in the stuff I've done, both at work and my hobby stuff, it hasn't been a big issue because of the tree shaking being so good. So I know for example, I have a friend who has made a web app that has a lot of documentation in it. And in that sort of situation, it's kind of dumb to need to load all the documentation for all the pages, for all languages at once. So that'd be a case where lazy loading would be good. Doesn't exist yet, so sucks for him. There's use case for it. In practice, it's not so bad that it's missing.
We're talking about this recreating DOM. Is that done every frame? Or how often do you actually recreate DOM? And if it is done every frame, how does it actually know where to or what to keep and what state the audio currently is in?
So this audio function that I've shown, that gets called every time, essentially like every time your view function gets called, like every time something happens, it also gets called. So this game, which is running at 60 FPS, then 60 times per second, then audio is called 60 times per second. But if you have something more simple, if you had a web page that just played audio at the start and like it was all planned out from the beginning, like at this time play this song, at this time play the sound effect, audio could play once, or the audio function could be called once, and that'd be it. From there, once the audio function is called, there's the audio framework. Like if I go back real quick, this audio element with audio, the thing that builds your application with audio supported. What it does is it checks the audio now compared with the audio from the last time audio was called. And then it does a little a diff against them. And essentially what it's just doing is it flattens out the entire audio data structure. So like right here, we're looking at a group with an audio, and then it's like inside this scale volume thing. It just flattens all that out and then just compares like, well, we have this audio with pop sound that's playing at this point in time. Do we see that in the new one? We do? Okay, those are probably the same thing. So let's not modify that. And then like, if this just started playing, they're like, okay, we didn't see this before, and now we do see that. Let's start playing it because we don't see anything corresponding. This is a bit of a distinction actually from the virtual DOM, because in the virtual DOM, if you have like a text input and it's, I don't know, somewhere on the page, and then you stop showing it there, but you show a different text input in like a nested component somewhere else, Elm won't understand those are the same thing. And as a result, you have a little annoying behavior where like your cursor will jump back to the start of the text because that's not tracked by Elm. In the audio DOM example, it will, I mean, it's not on a page, but like if, let's find a better example here. If I suddenly moved it right below audio, so it's not inside this case of anymore, or okay, sorry, that's a bad example because it's still inside this list. Let's say, I don't have any good example here. Let's just say we have another group, so we have this audio.group, but let's say we have another audio.group that's nested inside of it, and for some reason we have an if statement so that this audio can jump from here, like playing because this condition holds, to playing inside this other audio.group because the condition holds there. In that situation, the audio DOM will figure out that, oh, this is the same sound, even though it's in a totally different part of the data structure. The reason it's so thorough with figuring this out is because in JavaScript, the timer precision, that like if you ask what time it is, that precision's like inaccurate to a couple milliseconds. I think this is to like ward off Spectre attacks and other timing-based exploits. But because of this, I cannot play sound effects accurately. So if I were to stop a sound effect and then immediately start playing it again, there'd be some jump and you're like an actual, well, this one's called a pop sound, but there'd be like an actual pop sound or like, like waveform, nothing, waveform, that sort of thing. That's undesirable. So it does this, the audio DOM tries very hard to figure out if an audio has actually stopped playing or if it's just started playing in a different part of the data structure. So that's a bit of like the internals, what's going on. But once it's figured out this diff, then it just sends out, internally it's doing start, stop, set volume itself. It's just sending those off to the web audio API. And that's what it does in the end. Yeah, a bit of internals, how it all works. I hope I answered the question. Okay. Cool. Everyone's good? Nope. Yep. There you go. Exactly. Yeah. This is if you had like browser.element, same idea, but this one is element with audio. Yeah. There's also audio application with audio. There's no audio sandbox with audio because sandbox doesn't support commands. Which is like, okay, what's the point of having audio then? So there's not that, but element, document, and application, also Lambda, but not relevant here. Those are all supported. Yes.
Regarding CSS,
Mm-hmm. In Elm, you have a variety of options. You can just do pure CSS, of course, CSS file, load it in. But you have other options. There's Elm CSS, which is like CSS but statically typed. And then what you're doing is instead of having a CSS file, inside your program you define up, like at runtime, you define the CSS that should be visible, and then you can use that in your HTML or whatever. In the case of this program, I'm using a package called Elm UI, and that's a bit of a higher abstraction where you're not working with CSS directly at all. Instead, you have things like column, row. You have things like background color, background rounded. It's basically done its own abstraction over how to visually draw things. And I use it because it's much nicer. CSS has a lot of like edge cases where things are visually laid out in a way that's unexpected, whereas Elm UI tries very hard to have a nicer abstraction. And this portion here, so this is like Elm UI, and then the thing on the right, thing on your right, that's WebGL canvas. So that's these are all like just rectangles with a texture drawn on top of them. Yep. If you want to know more, I can talk about it afterwards. Mm-hmm. Mm-hmm. If you play them at the same time, same volume, then I guess it'd just be 5 times louder. Like they're all playing on top of each other. I just mentioned earlier how like there's some wiggle room between like when a sound plays, but if you play them all at the same time, then they should all start at the same time. You might just then ask, okay, but didn't I just say stopping a sound and starting a sound would get them like start differently? I think in that case, because you're stopping one and starting another one, there's some wiggle room. But if you start all of them at the same time, then they should just play on top of each other. It'd be easier, of course, to just scale the volume by 5, but you do you. Yeah. Yeah. That's a good point, actually. Here, I'm just showing like it says sound. This has another problem, which is you want to play the same sound multiple times. Well, you can't really hear because you can only reference a specific sound resource. So you have to make this a little more complicated to have sound IDs. So you say which sound, you play it, and you get back an ID so that you can reference it if you need to set the volume on that specific ID or something. That's another disadvantage with doing it this way, is that it's harder to play multiple sounds of the same resource. But yeah, so with this approach, it's very easy to play the same sound multiple times, as is the case with the bullet thing. I don't need to worry about which instance of the sound it is. That's just all. It's not even something I need to think about when I'm doing it. Yep. Yeah. So, up here we have audio scale volume 0.5. I could replace this with some model dot sound effect volume. And then down here I could have this thing here could be, have another one of these that's, music volume scaling. And then I could just, stick 3 sliders right here. Something like that. In that case, I probably would also, I would probably add another audio group and put this and this in it so that I can scale the sound effect volume for all of those. And this one also. Yeah, it just, however you want to group it, essentially. Yep. The pop sound is just me. The pop sound? No, because the code is not open source. I can make the code open source, but I didn't, and because this sound is sitting in the code. And but if anyone's interested, I can open source the presentation here. This music, I've commented here the song. My sister suggested the song. I was just like, hey, I need a song. It doesn't need to be thematically appropriate, but she gave a song that felt reasonable, I guess. And then the game over sound. Okay, I didn't add a indication here, but this is the Kirby game over sound for Kirby Nightmare in Dreamland. So okay, yeah. Which I don't know, sounded appropriate. Yeah. Yeah, right. The original question. Sorry. Yeah, if you just Google like free sound effects, it's mostly an issue of quantity over quality. It's hard to find good sounds or sounds that fit together, because like here they don't fit together at all. That works for this presentation, but if you're making a more serious game, then no. Yeah, I don't know like of any like really great source. Unless I guess if you're going for a specific style, maybe there's some website that handles like 8-bit music or something. There's also a great tool called BFXR that generates like 8-bit sound effects. But yeah, in general, sound effects are not my forte. So yeah. I just realized that I've not been repeating the questions. No one in the live stream has a clue what I'm talking about. Maybe I can annotate it afterwards. Yeah. Okay. Dare to clap? Thank you. Thank you so much for the questions. This was a really short presentation otherwise. So yeah, that was great. I'll just end the stream then.